A calculated column in Excel typically looks something like this. That formula is typically filled down. Your data set is refreshed, which adds an additional 1,000 records to your table. You copy and paste over your old data and make sure that you remember to update your formula to make sure they cover the additional 1,000 records. Although all of this has been substantially improved through the use of a new table methodology introduced in Excel 2007, which introduces named column references using the square bracket notation, it still suffers from the fact that a formula is not guaranteed to cover every row, which can lead to errors. The other problem is that when you start to get too many formulas, Excel can slow down massively. Part of this is to do with the fact that Excel recalculates every formula every time a cell has been activated. This fundamental architecture of Excel means that people are often required to summarize the data before applying any calculations to minimize the number of formulas that need to run. Alternatively, a copy and paste special values is used to remove the formulas, which removes the logic of how the results was achieved, making reproducibility more difficult. None of this is really an issue in R, which can run calculations across millions of records instantaneously. In this example, we're going to go over how to create some calculated columns using the mutate function in R. We're going to start off our script by loading the Tidyverse library, followed by loading some data into an object called dt using the read CSV function. The example files that come with this course come with a file called employeedata.csv. This is public employee data that comes from the Montana State Government website. Control Enter to load that data. And let's click on the View button over here to take a quick look at what our data looks like. Let's just shrink this panel over. So we can see here that we've got employee data, a record for each year, the base salary amount. Now the amount here looks quite low. The reason for this is because if we look over to the frequency column, we can see that this represents an hourly rate. Now the fact that we have a frequency column makes me want to find out what other values are in here. Now Excel has a relatively nice feature where when you apply a filter to a table, you can click on a drop-down to see all the different options that are available. This can be quite handy, although when your data set gets quite large and you have a lot of values, it can start to make Excel run quite slow as it runs through all of the values in your list. R also has some sorting and filtering for our values, but it doesn't have the same drop-down menu for seeing what all the different values are. Instead, if we want to see what all the unique values of the frequency column are, then we're going to use a function called unique. I'm going to come down to the console here, and I'm going to type in a command directly into here. Unique. Our table name, which is dt. And if I hit the $, I can get access to all of the columns that are available to this table. I'm going to select frequency and hit tab to select it, and then I can hit enter to see the results. I can see here we just have two values, hourly and daily. Another way to get these type of values is to pivot out data, and we'll cover off how to do that later on in the pivoting section. For now, we're going to see how we can make more sense of this data by adding some calculated columns. Now we can also see over here that we have a total column. We have a figure here which is slightly higher than the base amount. What this tells me is that we have a value which is comprised of effectively the base plus the bonus. We can use this column to do a calculation to split out the bonus amount. So let's come back to our script to add these calculated columns. We're going to start off by typing the name of our table, and then hitting Ctrl-Shift-M to fill in this pipe operator for us, followed by the function mutate. In our mutate function, we're going to add 3 new columns: annual base salary, annual total compensation, and annual bonus. Annual bonus is going to be equal to annual total compensation minus annual base salary. But we'll need to calculate these other 2 values first. Note that each of these columns will need to be separated by a comma, and we type equals after the column name to start typing the formula. For this formula, we're going to use the if-else function, which is very similar to the if function inside Excel. The first part of this function is a conditional statement, followed by what to do if that condition is true, followed by what to do if that condition is false. In this example, we're going to check to see if the frequency is equal to hourly. For this condition, I'm going to enter frequency equal to hourly. Notice in R, I have to use 2 equal signs for equivalency. One equal sign is used for assignment. This is important in R because we'll be assigning our values to variables instead of just cells. In Excel, this doesn't really matter because everything just gets assigned to cells anyway. So the first equal sign in any formula in Excel is really just a formality to say that this is a formula. There's no further assignment done after that, which is why Excel can use single equal signs within its formulas. Coming back to our if statement, if the frequency is hourly, then we want to multiply the base times 40 hours per week times 52 weeks per year. If the frequency is not hourly, we're looking at a daily rate, in which case we want to look at base times 5 days a week times 52 weeks a year. Now the annual total compensation column is going to be very similar to this, so we could probably actually copy this formula and simply change base to total. Notice how if you can't remember all the names of your columns, you can always hit Tab to help you out. Now that the formulas are complete, I can hit Ctrl-Enter to see the results. It's a bit hard to see here since there's too many columns now in our data. To make this easier to see, I can take all of these results and pipe them into the command View. If I hit Ctrl-Enter now, it will take all these results and display them in a table view. And at the end here, we have all of our calculated columns. Note that there's one last step here. All of these calculated columns have been added to a temporary table which hasn't been saved yet. So if we click View again on our original table, we can see that none of these calculated columns actually exist here. To save our calculated columns back to this table, we'll come back to our script, and before the mutate sign, we're going to type in DT and add the assignment operator. Let's get rid of the View command and hit Ctrl-Enter. Now if we come over to our table and click View, we can see that DT now also contains our calculated columns. This has been a lecture from my course, R Reporting and Analytics for Excel Users.